be 0. And around quarter dent is, for the system, it's around 2.75 to 3. That's about where you want your gain. And then your ultimately dent is around 4. Here's a graph telling a little bit about the controller gain obtained from the root locus. This is for different damping ratios, and the blue is the low range, the red is the medium range, and the green is the upper range. And as you can see, when I'll show you that for each damping ratio, the gain gets larger. And I'll hand it off to Casey now so that he can start telling you about the proportionally only model.
Alright. This is the proportional only control model, where that's the height of the first peak and that's the height of the second peak. The height of the second peak divided by the height of the first peak will give you the decay ratio, and from this we can also find our offset, and we can find our settling time for each value of casing range for controller gain. This was one of the models for the mid-range. This was decided, that is not the right label. That should be, okay, yeah it is. Alright, this was decided to be the ultimate controller gain for this mid-range, and that should be a 6 for the KC instead of a 4. I don't know how that 4 got in there. This is for half decay, and this was found by doing 10 different experiments, and by trial and error we found the decay ratios for half decay, quarter decay, and 1/10 and 1/500. And these are just examples along with their settling time and offset for each of the ones that we found. And then that's the one for quarter decay with a KC of 2.6 and decay ratio of 0.25 and settling time of 4 seconds and offset of 1.1. That's the model for 1/10 decay, which gave a KC of 2. That's the model for 1/500 decay, which gave a KC of 0.68. And then this is the model for critical decay, which gave a KC of 0.06 for the mid-range. This is the data for each of the ranges, where the green is the high operational range, the red is the middle operational range, and the blue is the low operational range. These are plotted, the KC values for different decay ratios from ultimate to critical, where they increase as they go from critical to ultimate. This is settling time. The ultimate never settles, so it's actually infinity, but you can't plot that. And for 1/2 and 1/4 and 1/10 and 1/500 and critical, the settling time decreases for each of the operational ranges. The offset for the ultimate was 0, and the offset for when the decay ratio decreased, the offset increases. This is an example of the proportional control experiment for the mid-range. This one was for the ultimate gain, which was found to be 6 from the previous model. And the TU can be used for the ultimate one to find the ultimate frequency. That will be listed later for all of the experiments. And then the offset was found to be 1. And that first cycle label means absolutely nothing for this. This is another one for the mid-range where the KC was 5, which is just a random number chosen. And it had a decay ratio of 0.57. It was underdamped. It had a sailing time of 7 and an offset of 0.8. This was the KCU that we found from the root locus, and it had a decay ratio of 0.4 and a sailing time of 6 and an offset of 1 when we ran it through the proportional control experiment. This KC was using the tuning equation, which was said the KC for quarter decay was 1/2 of the ultimate KC, which our ultimate KC was 6 from the first plot. And it had a decay ratio of 0.27, which is close to a quarter decay, and a sailing time of 4.5 and an offset of 1.2. This was just another experiment done, and this one was overdamped. I had a KC of 1 and a decay ratio of 0. The settling time was 2, and the offset was 2. And then another was ran with a KC of 0, which it didn't even jump. It just stayed at 30. Yeah, 30. And this is for the low range, and on the bottom are the values of KC, and then our ultimate gain that we found from the experiments is labeled along with the one using the tuning parameter, which is the KCU divided by 2, and then the experiment that we ran for the root locus. And these are the decay ratios that they gave for each experiment ran in the low range. Same thing here with the mid-range. They had almost the same, but the KCs aren't in order from lowest to greatest, so it won't look the same as the rest of them. This is for the high range, the decay ratios, and it used different numbers other than 0 and 1. It used 1 and 2, where it actually found numbers. 4, the KCU was 6, and the KCU over 2 was 3. And the root locus KCU gave a decay ratio of 5.8 for that one. Not 5.8, but sailing time for the low range. There was no sailing time for the ultimate KCU that was found in the experiment because it never settled. There should be one for 5. And then it was just monotonic for 0, so it was already settled. And then the KCU from the root locus, it should have had something. For the mid-range, the KCU for 6, there's nothing listed, but that's because it never settles. And then the root locus ended up being about 6 seconds. From the tuning equation, it ended up being about 4.5 seconds. For the high range, for the KCU, it never settled. For the tuning equation, it ended up being about 3 seconds. And then from the root locus KCU, it ended up being about 6 seconds. This is a list of the KCs for each range that was found. The KCUs found for each range, which was 7 for the low and 6 for the middle and the high range. This was the TU found from the ultimate experiments, like the first one shown, for each of the ranges, where it was 3 for the low and 2 for the middle and the high range. This is the ultimate frequency for the low, middle, and high, where the low ended up being about 4.5, the middle was close to 0.4, and the high was closer to 0.5. Yeah.
Clap.